Right. AP Psych students, I am glad to meet you, albeit through video the first time. I'm here to talk to you about data and statistics, and I want to give lots of credit to my good friend Dr. Laura Storian. These are her slides, and she's taught AP Psych for a long time. Okay, so for my part, I'm actually an engineer, researcher, and data scientist, and I teach math here at Mill Springs for a couple reasons, mostly because I love teaching and I love math, but I am very excited to share this with you. So, without any further ado, I called my first slide, or the title of the little bit we're going to do, all about data and statistics. So over here on the left, you see just columns and columns of numbers. It's an Excel spreadsheet, and those could easily be the result of a sociological experiment, a psychological experiment, any kind of data collection. And it's not very meaningful. I mean, it's not possible to look through countless numbers and make sense of it. And so the way we make sense of data is through statistics. Okay, over on the right, you see a collection of data that is comparing total screen time, which is the black line, to electronic devices, which is the gray line, to TV and video games, which is the dashed line. And what we're comparing is screen time versus age and years. And so this, you can imagine, was a lot of data collected. And what you can do is summarize that data and create trend lines by looking at the average and the spread at each age. So let's say we went out and we were able to collect 100,000 pieces of data about 7-year-olds. Well, the average, the mean, is right where that dot is, and the little bars are showing a relative measure of how far spread out the data is. So you can see when it's a very small spread, it means it's really clustered in the middle. That's the kind of stuff we're going to talk about today. The bottom is even more simple. Sometimes you do want to compare two different variables, but a lot of times you just want to look at data and see how frequently it occurs. And so the bottom is the most typical kind of probability distribution that you'll ever encounter, and that is called the normal distribution. And so almost any physical measurements you make, height, weight, this is IQ, and so the average IQ is 100, because it's a ratio of your intellectual age to your chronological age. And the way it works is 68% of people fall within what's called one standard deviation of the mean. For AP Psych, you need to know how to read scientific data and write intelligently, but you're not going to be doing straight up statistics. That's AP Stat. So we're going to start with, why do we even do this? Statistical reasoning lets you analyze and interpret data in a way that you can't just see with your unaided eye. Like on that first slide, I showed you like all those tons of numbers on the left. That's pretty meaningless, but when you look on the right, you can tell a lot about what the story the data is telling. And so this is a pie chart here, and it is a composition of ethnicity within cities. And so you can very quickly look at that and grasp what percent is distributed across the different races in urban places. You could not tell that if I just presented you with a big long list of numbers. Another important piece of this is that it's much more meaningful to describe data by representing it visually. However, the caveat there is you have to be really careful about how you represent it visually. And a good example is shown below, where over on the right is just like if you said, okay, this is the percentage of brands of trucks that are still functioning after 10 years. So it gets graphed from 0 to 100%, and we're looking at 4 different brands. Well, they all look really, and so instead of going from 0 to 100, we're going to go from 95 to 100. And that lets us see there's actually a significant difference between the first brand that we're trying to compare and brands X, Y, and Z. So scale matters. How you represent the data matters visually. The next one of the big things in AP Psych that you need to know are what are measures of central tendency and what are measures of spread or deviation. So measures of central tendency is something you've probably done a lot in math. And those are 3 different measures that give you an idea of how central the data is. and those are the mode, so that's the most frequently occurring number. The mean, which is an arithmetic average, so you add up all the scores, and then you divide by the number of scores. Or the median, which is if you put them all in order, the median is what happens exactly in the middle. And this is one of the things about measures of central tendency is it's a really quick way to see if you have a skewed or a balanced distribution. So skewed means your distribution of data, a lot of it's clustered on one side. It's not evenly spread across the whole distribution. So you can see here that all the families, income per family per thousands of dollars, well, it sounds not too bad because the average family makes $70,000 a year. However, when you look at the median, if you line up all the families in America, you find out the median family is actually around $30,000, and the mode, the one that occurs the most often, is $20,000 a year. So it's very unbalanced. And the reason the mean is so high is actually because we have these big numbers out here at 475,000 and 710,000. And so that making an equal weight, which is what the average does, is really offset by those high numbers versus the low numbers. So this is what's called a skewed distribution. It's just not evenly balanced. This is an example of a balanced distribution that we're going to use in a couple of other different examples when we go through this. So a balanced distribution is one where, it's kind of evenly spread. And this particular one it was part of a quality analysis in a manufacturing facility. And so we're looking at what is the weight of cereal in a box when it's produced and sent out by machine number 2. And so they have 50 different samples of the cereal box were taken, and the weights vary from 12.15 up to 12.75. And they are fairly evenly distributed. Now notice it's not perfect because you don't really expect data to be perfect, but it does have the overlying dark blue line is the normal distribution that best fits this data. So we're going to talk about normal distribution a bit more. But here you can see the average or the mean arithmetic average is 12.4. And so that's, pretty close to the center of 12.15 to 12.75. But what's more important than that is the other measures of central tendency, that is the mode and the median, are really close to the mean. So when all of them are close together, then we call that a balanced distribution. And when mean, median, and mode are very different, we call that a skewed distribution. I appreciate you joining me for this, what turned out to be a little bit longer than I expected video, and I look forward to working with you.